that to them? Yeah. Third hour? Probably. Okay, here we go. You need to have two things out. Number one, you need to have out this sheet right here that looks like what I have on the board right now. But then you also have to have out your assignments. If you skip this section and move on to the part that looks like, you want to find the section that looks like this. Okay? You want to find the section that looks like that. So if I pull that up on the board, you want to find the section that looks like this. Have both of those out together. We ready? On your mark, get set, go. Here we go. Yes, microphone is on, video is on. We are golden. So this is the circle of life. Circle of life, Simba, right? Lions, look at it, all connects together. Christian the lion. Oh, let's fill this out. 0 degrees. And over here, I'll put 180 degrees. Let's do some more degrees. Before that, Laura, before. Are you trying to find it? Yep, flip the page. And one more. There you are. And I'm going to put 90 here. What's this one? 60. 45. And 30. I'm not going to fill it all out for you because it's part of your homework. But I'm going to get you started with it so you can understand what we're doing today and why. 0 degrees is the same as 0 radians. 0 degrees is the same as 0 radians. I'm going to put the radian right next to the degree. 180 degrees is the same as how many radians? Pi. 90 degrees is, or pi over 2. How does 60 compare to 180? It's 1/3, so therefore 60 is going to be pi over 3. Look at how smart you are. 45, pi over 4, 30, pi over 6. Somebody asked what happened to pi over 5. Well, that would be 36 degrees, and 36 degrees is not an angle that we use, and I'll show you why. So, here's what we're trying to do today. Here's the big idea. We want to find the coordinate where the angle intersects the circle. What is this coordinate right there? 1, 0. Over 1, up 0. How about this one? 0, 1. How about this one back here? So the big idea that we want to try to work with is being able to find these other coordinates. And they're not real nice numbers. And how do we determine it? Well, we're going to use some geometry, and it's really going to be cool. You're really going to like it. But what I need to do here is, as I figure those out, I just want you to understand that everybody agreed that this x value here, that it's going to be less than 1. That you're never going to go over more than 1, right? You're going to be going less than 1. And then the y value here, you're going to be going up a certain amount. Maybe like, I don't know, whatever you go up, it's not going to be as much as 1, right? It's going to be bigger than 0, but less than 1. Let's try to figure those out. I want you to flip to your notes and look at this section right here. We need to talk about the geometry of special right triangles. This is a beautiful lesson that happens in geometry. Somehow we make it just disgusting. I don't get it. I think sometimes it's our perception. This is like when your teachers cover this, you're supposed to be like, oh, that was super helpful. Like, thank you. That's like Christmas. But sometimes we're like, I don't like it. Let's see how it works out. If you have a 30, 60, 90 triangle, what's beautiful about the 30, 60, 90 is it's exactly half of a 60, 60, 60. Whoop, whoop. What's special about a 60, 60, 60 triangle? It's equilateral and equiangular, which means that all the sides are the same, right? So we can use that and say, well, suppose we cut it in half. Okay, we dice it in half. There you go. Well, if we cut it in half, then the sides aren't all the same anymore, are they? But suppose this used to have, or suppose it had a length of 12, what is then going to be the length of the short side? 6, because it got cut in half, right? Well, that's easy. Does anybody know what this side is? Close. 6 roots of 3. And we'll talk about that. But this is always double that, right? And to get this one, you just multiply by the root of 3. Every single time. Like, watch. Watch how quickly this works. Suppose that this side here is 4. What's this side? 8. What's this side? A lot of people ask, why the root of 3? You want to see, right? Why the root of 3? Suppose you have a triangle where this is A, then this would be 2A, right? I'm going to find B. I have A squared plus B squared is equal to that squared. What's 2A squared? 4A squared, right? Got to solve for B, don't I? So subtract the A squared. I get B squared is equal to 3A squared. What do I have to do to both sides? Square root. What's the square root of B squared? B. And then if you simplify this square root, you have A times the root of 3. That's why it's always this thing times the root of 3. That's a proof. Like we just proved it's always A roots of 3. You like that proof. No. You like that proof. You're like, that's really cool. Look at that. Look at that. Hey, let's look at another really cool triangle, okay? 45, 45, 90. I'm struggling here. I got 2 jacks sitting next to each other. This is too much for me to take in right now. What's true about a 45, 45, 90? 2 sides are the same, right? It's called an isosceles right triangle. Well, that means that if this side here was, say, 7, then what would this side be? 7, right? How about the hypotenuse? 7 roots of 2. For a 45, 45, 90, we use the root of 2. See, here's how I kind of remember it. 30, 60, 90 are all divisible by 3, right? So it uses the square root of 3. Whereas in the 45, 45, 90, 2 sides are the same, 2 angles are the same, so therefore use the square root of 2. That's how I always think of it. 2s and 3s. So let me try to switch this up and see if you guys can figure this out. Suppose instead of 7, suppose I had a different number. Suppose I had 5. Well, what would this side be? 5. And this would be? Okay, wow, you're smart. All right, I'm going to trick you now. We're going to get you this time. What if instead of 5 roots of 2 or 5, suppose that I put 10 roots of 2 here. So what would this side be? And this would be, oh man, you guys are still really smart. What if we switch it up a little bit more? What if I say this side up there is 3? Then what's this side? 9. So in order to go from this side to this side, you multiply by the square root of 2, right? So to go from the hypotenuse to the leg, we divide by the root of 2, right? So it'd be 3 over the root of 2. Can you leave it as 3 over the root of 2? No. So you multiply the top and bottom by the root of 2, you get 3 roots of 2 over 2. And this would be 3 roots of 2 over 2 as well. Or 1.5 roots of 2. Goodbye. Okay, one last piece to kind of connect your learning. Suppose the 60-degree angle is on the bottom now. No big deal. Suppose that this has a length of, 8. Then what's this? 4. And what's this? 4 roots of 3. With the 30, 60, 90, it's the root of 3. With the 45, 49, it's the root of 2. Gav? I thought you had a question or a comment. Connecting the dots. Look at that. Connect the dots. Let's go. All right, you are now ready. What we like to do is find these coordinates, and in order to do so, we're going to start with pi over 4. Okay, we're going to do 4 examples here for you to engage, ask questions, and figure this piece out. So pi over 4 means that if I were looking at this guy right here, we want to find this point right here. We call it a terminal point, because if you were to rotate 45 degrees or pi over 4, at what value does it intersect the unit circle? Super important to come up with that value. So how do we do it? We really kind of take 3 steps. And the first step that we take is we figure out what pi over 4 is in degrees. Pi over 4 is how many degrees? 45. Second step is we figure out what kind of special triangle fits in that space. If it's 45-degree angle, I draw it like that. So anybody know what kind of special right triangle I'm going to have? Yep, 45, 45, 90. And the third step is then, so are you okay with the first 2 steps so far? Yeah. So the third step is we solve the triangle. Then we find the lengths of all its sides. If we're in the unit circle, what's the length of the radius all the time in the unit circle? 1. So therefore, this length right here is 1. So if this is 1, what do I do to the hypotenuse to come up with the leg in a 45, 45, 90? What do I do with the hypotenuse to come up with the leg? I divide by the root of 2. And watch, you get 1 over the root of 2. Can you leave it like that? Nope. Multiply top and bottom by the root of 2, and you get root of 2 over 2. So if I know that the bottom leg is the root of 2 over 2, how about this up and down leg? It's the same thing. So therefore, this coordinate right here is going to have an x value. The x value is this part, and the y value is this part. So the x value is the horizontal component, and the y value is the vertical component. And that is your coordinate. So if we flip back to your worksheet that you're going to be doing, when you see this pi over 4 or 45 degrees, those correspond with a terminal point of root of 2 over 2 and root of 2 over 2. And you will use that many, many times before the year is over. Not too bad? Okay, 3 more. Let's try to go through the process together. What's going to be my first step for 4 pi over 3? Find it in degrees. Some people say they can't do that without looking at their notes. Stop it, folks. Don't look at your notes. Do this. Do 180 divided by pi. When I see 4 pi over 3, I think of 240 degrees right away. How do I do that? Well, you know that the pi's cancel. If I see something over 3, how many degrees do you think I think of? 60. And then I multiply it by 4. And 4 times 60 is 240. See, 180 divided by 3 is 60, times 4 is 240. So that's an easy conversion for us. 240 degrees. Places us in which quadrant? Third. Anybody, what's the reference angle in the third quadrant? The reference angle is the angle formed between the x-axis and the terminal side of the angle. It's this angle right here. 60. Remember how we found reference angles yesterday? You always want to come up with that reference angle when you're doing this. It's always against the x-axis. And we have 30 degrees over here. So what kind of special right triangle do we have? 30, 60, 90. Well, now let's solve the triangle. Okay, what's the length of the hypotenuse? Always 1 because we're in the unit circle. What do I do to the hypotenuse to come up with the short side? Divide it by 2 and I get a half. Once I have the short side, what do I do to the short side to get the long side? Times by the root of 3. I'll only do this once. If you take 1/2 and you multiply it by the root of 3, notice you get the root of 3 over 2. So this length is the root of 3 over 2. What up? Thank you. All right, let's go. So we've got that. So I've got these coordinates. So I've got an x, y coordinate. Somebody, what's the x value of the coordinate? 1/2? What, negative 1/2? Why would it be negative? Oh, it's in the third quadrant. What's the vertical? What's the y value? Not too bad, huh?
So that point is the one that's on like outside of the circle.
That's this location right here. And if you were to actually compute this, it would be negative 0.5 and negative 0.866. And if you look at this and say, well, this is 0, negative 1, and this is negative 1, 0, hopefully you can convince yourself that this thing right here looks like it's over about a half a unit, and it's down about 0.866. See what I'm saying? All right, 2 more. And the last one's the easiest one of all. You guys are doing well. Help me out. Where do I start? What?
Where's negative 5?
Yeah.
Yeah.
Help me.
3. You have to make it
You see pi over 6 and you think of 30. So 5/30s is going to be?
150.
So negative 150 degrees. We're using negative 150. Where's that going to bring me? Which quadrant?
The third.
Cool. So what's my reference angle? 30. Very good. Yes. Are you ready?
Yeah.
Okay. Do you agree that this rotation is negative 150? And this rotation to here is negative 180? So it's always going to be the angle formed between the terminal side and the x-axis. Always. Good question.
The terminal side is the...
This is the initial side. It's where you start. Terminal side is where you end. 90-degree angle. What kind of special right triangle do I have? 30, 60, 90. What is always the length of the radius or the hypotenuse? 1. Why?
Because that's the radius of the circle.
It's the unit circle. So what's the length of the short side? Half of 1, which is a half. What do I do to the short side to get the long side? So root of 3 over 2. I've solved it. Let's name the coordinate. What's the x value? Negative root of 3 over 2. The horizontal, and then the vertical would be negative 1/2. Yes.
Now, on our unit circle, this is for birds. So on our unit circle, if we write that down, would it just be 3?
Yeah, you see,
Sort of 3
I
over
don't
2, then 1/2?
You mean for 150?
Yeah.
So for 150, it would be in the second quadrant, right?
So I'll be negative.
And it would be a negative root of 3 over 2 in the positive 1/2. Okay. All right. Last one. Last one. You see negative pi over 2. What do you think of? Close. Negative 90 degrees. Pi is 180, so pi over 2 is 90. So where is negative 90 degrees going to bring me? Right down there, right? Now, here's what everybody does. And don't make this mistake, because this is the easiest problem of all. People start to sketch a triangle. You don't need to sketch a triangle. The whole question is, where does it cross the unit circle? Can't I just look at that and know where it crosses the unit circle? Yeah, 0, -1. I don't need to make a triangle. Get my point? And so we've got that point, 0, -1. So here's what you're going to be doing. Turn to your assignment. Critical assignment, crucial to your learning. Got to figure it all out. I've got circles with radian values. You'll be doing exactly what we were doing for these 2 pages, okay? After that, you head on over and you complete the entire unit circle. You should be able to complete the entire piece. Somebody was doing this morning and they said, this seems tough. And 5 minutes later, they said, I see a pattern and now this is easy. Folks, we don't have time to teach you everything that should happen in math. There's some things when we design assignments where we want you to see a pattern and learn from it. And that's part of what this purpose is as well. So hopefully you see a pattern and it becomes beautiful. And when it does, the unit circle will seem easier. If you don't see the pattern, I'm going to show it to you at the beginning of class tomorrow. Okay? Ready, set, go.